Number 3 is x equals 2y minus y squared. X equals y, and we're rotating this about the x-axis. Well, the x-axis is horizontal. Since the x-axis is horizontal, we know that we need to integrate with respect to y. Let's go ahead and graph all of this. Well, if we're looking at this first one right here, this is a parabola because y is squared. Let's go ahead and find the y-intercepts, and let's find the vertex of this parabola so it's easier to graph. My y-intercepts are going to be found by letting x equal 0. So I say 0 is equal to 2y minus y squared. If I factor out a y, I'm left with 2 minus y. So I know I cross the y-axis at 0 and at 2. For my completing the square, first I rewrite it in descending order. Then I factor out the negative. And don't forget to add the plus blank. But we're really subtracting because of that minus sign, so add a plus blank on the outside. And then we factor, and this becomes y, and then half of a negative 2 is a negative 1 squared. Well, negative 1 squared is a 1. That's the number we write in the blank. Move this over with x. We have x minus 1 is equal to the negative of y minus 1 squared. So the vertex here is the number opposite with x is 1. The number opposite with y is 1. So we're going to go ahead and graph this. So I know that my vertex is 1, 1, and that I cross the y-axis at 2 and at 0, and that this parabola opened to the left, so it looks like that. Then I have x equal y. Well, x equal y is the same as y equal x, and if it's y equal x, that's just a line. Its y-intercept is 0, and its slope is 1, so up 1 over 1. And we draw on that line, and it looks like that. So the area is this tiny sliver right in here, and we're going to take that tiny sliver and we're going to rotate it about the x-axis. The first thing is, can we see our limits of integration in y? Yes, because we drew it well. If we didn't draw it well, it would be where these two things, the blue, intersects with the green. So if we find that point of intersection, 2y minus y squared equals y, moving everything over to the right-hand side, so my y squared is positive, I end up with positive y squared minus y. Factoring out a y, I end up with y equals 0 and y equal 1. Definitely can see that they intersect at y equals 0 and y equal 1. So I do have my limits of integration. My volume so far is 2 pi times the integral from 0 to 1. Now I need a radius and a height. So your radius is always perpendicular to your axis of rotation. So my radius is going to be this guy right here. This is my radius. Well, that's just a y movement, right? To get up there, I moved y units, so my radius here is just y. Recall, like I said on the very first page, if your axis of rotation is just the x-axis, then your radius is always just going to be y. Since the axis of rotation here is the x-axis, my radius is going to be y. The last thing that I have is the height. Well, the height's going to be the distance on the inside here, and then that height, well, it's got to be blue curve, this guy right here, this blue curve, minus the green curve. Well, the blue curve, remember, was equal to 2y minus y squared, and the green curve, remember, is just y, so it's got to be whatever 2y minus y squared, the parabola, minus the line y is. If I combine like terms there, that's just going to be y minus y squared. So my height is going to be y minus y squared. Coming over here, y minus y squared, and then dy. Now what I want to do is I want to distribute and then integrate. So I have y squared minus y cubed dy. Integrating, we end up with y to the third over 3 minus y to the fourth over 4, and this gets evaluated from 0 to 1. Plugging in those limits of integration, we're going to have 1 cubed over 3 minus 1 to the fourth over 4, and then minus a bunch of zeros. If we put that in a calculator, and we just really need it to be 1/3 minus minus 1/4. And we're going to go ahead and take this number and multiply it by 2 to find our final answer. Make that into a fraction, and we end up with 1/6. So our answer is going to be pi over 6. Let's look at the next example. We have y equals 1/3 x cubed, y equals 6x minus x squared, and we're going to be rotating this about the line x equal 3. Well, x equal 3 is vertical. Since that's vertical, we know that we have to integrate with respect to x. So I'm going to go ahead and complete the square on this guy here and draw that parabola first. And then after I do that, I'll handle the y equals 1/3 x cubed. If we find the x-intercepts, let y equal 0. We know we can factor out an x quickly, and then we'd be left with 6 minus x. So we know we cross the x-axis at 0 and at 6. If we were to complete the square, rewriting it as the negative of x squared plus 6x, factoring out the negative, adding in the plus blank, and on the outside also a plus blank because we're really subtracting. Knowing that it's going to be half of the coefficient of the linear term, which is negative 3. I take that number and I square it and I get 9. Moving this number over with y, we have y minus 9 is equal to the negative of x minus 3 squared. So the vertex here, number opposite with x is 3, number opposite with y is 9. If I were to go ahead and graph this parabola with all that information, I know that my vertex is 3, 9, and that I cross the x-axis at 0 and 6, and that I'm a parabola that opens down. The next thing I have is this guy right here, our y equals 1/3 x cubed. Well, we can always put that in a calculator if we have no idea what that looks like. So y equals 1/3 x cubed is just going to be a cubic function, and it's going to look like the stretched out capital letter N. So what we can do is just use some points to graph it. When x is equal to 0, y would also equal 0. When x is equal to 3, we would have 3 cubed, which is 27, times a third, which is 9. So we plug in those points, and we look just like that. And that is my y equals 1/3 x cubed. So the region is this guy right here because that's bounded between the parabola and the cubic function. And I know that I'm going to be rotating this guy right here around this line x equals 3. The first thing I ask myself is, can I find the limits of integration in x? Yes, I'm going from 0 to 3. Then I need the radius and the height. Well, this is the first time that I'm not rotating around the x-axis or the y-axis, so I need to be a little more careful for my radius. Typically, we said that the radius was just going to be from the axis of rotation to the yellow area. Well, the thing is, your point is going to start over here at the y-axis. What has to happen is that it has to travel all the way to x equal 3, and then it has to move back x units. What that means is that our radius is going to be, again, all the way to 3 because 3 is further to the right, and then minus x because we need to get back these units that I have to travel. So my radius is 3 minus x. Then I need to find the height. Well, the height is just going to be the distance inside of here. This is my height. Well, my height is going to equal green, which was 6x minus x squared, minus blue, which is your 1/3 x cubed. Well, we can't combine any like terms there, so it's just going to be 6x minus x squared minus 1/3 x cubed. Let's put in our height here. 6x minus x squared minus 1/3 x cubed. Now let's distribute, and then we'll combine like terms, and then we'll integrate. So when I distribute, I end up with 18x minus 3x squared minus x cubed, and then minus 6x squared plus x cubed, and then plus 1/3 x to the 4th. Combining like terms, We have 18x, and then minus 3x squared minus 6x squared is minus 9x squared. A negative x cubed plus an x cubed will cancel, and then plus 1/3 x to the 4th dx. Integrating, dividing this by 2, we have 9x squared. Dividing this by 3, we have 3x cubed. Dividing this by 5, we'd have x to the 5th over 15. And this gets evaluated from 0 to 3. Plugging in those limits of integration, 9 times 3 squared minus 3 times 3 cubed plus 3 to the 5th over 15. And then we plug in zeros, we're going to get a bunch of zeros. And then sticking that into a calculator, we'd have 9 times 3 squared minus 3 times 3 to the 3rd, and then plus 3 to the 5th divided by 15. Remember that we're going to have to take this answer and multiply it by 2, so let's go ahead and do that. So times 2. And then let's make that into a fraction, hit math, and then enter twice, and you get 162 over 5. So your volume here is going to be 162 pi over 5.